introduction to AR, augmented reality. So whether you call it AR or MR or XR, the combination of real-world elements and computer-generated graphics will underpin the metaverse experience for the average user. What started out as a game craze thanks to Pokémon Go has now evolved into a very useful technology for education, training, healthcare, manufacturing, and engineering. By 2024, an estimated 1.7 billion people will be experiencing AR on their mobiles, with the AR market expected to be worth over $18 billion in 2023. This week, we show you how to get started with the AR Foundation framework on Unity 3D in our continuing series on the platform. In this hands-on session, you'll learn how to create your first AR app in Unity and see it in action on your Android device. So thank you all for coming and enjoy.
You kind of forgot to take this, so Stream didn't catch it. It's fine. Okay, I'm just gonna clip this to here. I'm actually. Cool. Okay, so we're gonna do like an introductory session to AR Core and Unity. How many of you guys have used Unity before? Okay. Okay, so this is like our third Unity workshop. So we did cover the basics of Unity in previous workshops, although I will skim over them again so you guys get a brief like crash course. So this is what we will be covering. We'll do an introduction to AR, a few examples. So the biggest thing about AR is setting up your project, so user settings, project settings. Those are the slightly more different things. For those of you that are new to Unity, you might not understand what is happening, but I will run you through it. Okay, so this is what you just talked about. This is what the assembly does. Now before we move on to what AR is, because I was under the assumption that most of you guys know Unity, but I'll go over what it is. It's basically a framework for building games. It's a game engine. There are various kinds, one of them being Unreal Engine, Game Maker Studio. There's a bunch, Godot as well. Those are, if you want to know more about like in detail what Unity is and what it can do, you can look at our previous workshops, but the gist of it is you can use it to build games. It's a framework that's specifically streamlined to design and produce games. Previously we covered 2D games and then a 3D game, like it's a prototype more than anything. Now we're going to be covering AR. So just a quick heads up, you guys all should have Unity installed by now. If anything, you can use this link here. And all of our code will be on GitHub, so you guys can scan the QR code here and then just get a quick, it'll take you to my not so good GitHub page. Don't go to any other repo aside from this one. The rest are mostly empty and or incomplete. I'll just keep this up for a moment so you guys can go to the GitHub, because I'll just be copy pasting the code from, because I've already done this before, so I'll be copy pasting it from there. I won't be live coding it. So if you guys want to follow along, you guys will have to copy paste as well. Can I just get like a thumbs up if people have it up? Cool, okay. So these are other game engines that we use. So we have Unreal, Godot, and Game Maker Studio. Unreal is streamlined specifically for 3D graphics, more into like realistic 3D rendering. So not your AAA titles necessarily, because those tend to use proprietary engines. They make their own engines, so it's streamlined for that. But most of the time, Unreal Engine is used for 3D, like realistic 3D graphics, because it has a better rendering engine than Unity does. Godot specializes in 2D game development, so Metroidvanias or platformers, any 2D game that you can think of, side scrollers, whatever. All of these also have mobile game compatibility. Unreal Engine less so, but because it does realistic 3D rendering, a phone has trouble rendering all of that due to processing power, so they have a less of a focus on it. And lastly, we have Game Maker Studio, which is more of a legacy thing. It is updated quite often, but people tend to stick with Unreal and Unity. The reason we chose Unity is because aside from from all of them, Godot is the easiest, Unreal is the hardest. You program in C++. For Godot, you use its own script, GD script, and C# is what you use for Unity. C# is a little bit, at least in my opinion, an easier language to use than C++, and the tools provided in Unity are a lot more beginner friendly. Like they're more intuitive and less obtuse. So let's look at now what AR is. It's a form of XR, aka extended reality. That's what Unity refers to it as. You have virtual reality and AR, augmented reality. Virtual reality is when everything you see is virtually generated. You guys probably know this. Augmented reality is like the half of that, where it is you are taking inputs from the real world, but you can also generate virtual objects or like UI elements on your screen. So these are, well, not games. Games is a bad. So most AR applications aren't games. They are, well, just regular use applications. One of them you guys probably know is Pokémon Go. The other, at least the ones that I liked, were IKEA Place and Google Lens. Google Lens, I'm sure everyone knows about it. It has uses for a lot of different things. IKEA Place is neat because you get to design your home without actually spending any money on buying useless furniture. Pokémon Go, okay, I don't have to say anything about Pokémon Go. You guys, it was the game of 2016. Okay, so now let's go into actually building the project. So once you guys open Unity Hub, if you hit create a new project, oh, I should mention before, how many of you guys have just installed Unity, like right now? Okay, so for those of you that just installed Unity, you will also need to, so what you guys downloaded was the Unity Hub. What you need to install is a Unity editor. So, okay, this was there in the previous thing, but if you go to installs, also, if anyone was running into licensing issues, you make sure you guys are using a personal license, not a commercial one, because they will take royalties, and if you're not registered under a company, you can't use the commercial license. So just use the personal one, because we won't be publishing any of these games or making any money off of them. So yeah, for those of you who have Unity Hub, make sure you have a Unity version installed, Unity editor version. This is the version that I'm using. This is the one. Okay, you guys can see it. Cool. This is the one here. LTS stands for long-term support. So this is the stable version of Unity. The latest one is an unstable version, meaning there might be bugs within the editor itself. So why would you use that if you're unfamiliar with debugging? Once you guys have it installed, make sure that everyone has installed the Android SDK module. So when you install an editor, it has different platforms it can support: Windows, Linux, like Apple OS and Android. Make sure you have the Android one installed. You could also, for AR, you could also use Apple, but I have an Android device, so I stuck with Android. So yeah, make sure you have the Android module installed. Once you do that, if anyone is doing that right now, is anyone installing the module right now? Okay, I'll go slower then. Cool. So just this part, you guys don't need to do it live with me. You can, it's pretty simple steps. Make a new project, so you'll have a blue button that says new project. Once you do that, go to AR. So Unity gives you different templates that, although the environment is the same, these templates just give you a few settings that you can, like, you don't have to do manually. So it'll give you a bunch of new settings. It'll set up your scene. Okay, so I should explain. A scene is what you would think as of a level in Unity. So a scene is like, think of in terms of theatrics. So scene is the one thing that you could see at any given instance. So a scene is comprised of different objects because, again, C#, so it's an object-oriented programming language. So everything there is an object. if it's your scene, each object does different things. So if you, based on what template you pick, you will get a preset of different objects in your scene. For 2D, it's just a player camera and just a player camera, that's it. For 3D, since it has more to do with lighting and stuff, you have your camera and a directional light. For AR, you will have a bunch of AR objects, which I will cover soon, and a directional light. Again, I'll go over those in a bit. So here, you'll have the name of your project, just put in whatever name you like, and this is the directory you like to put in. Obviously, right now, this is a very tiny thing, so it doesn't matter where you put it, but games by nature are large files. So you don't want to put them in places that, like, you don't want to save it on your desktop or default locations. Pick a place that you want your games to be in, since they're large folders, and put it there. At least that's how I like to arrange it. Okay, so as for setting up your project, I hope at least most people are halfway done with the Android SDK. Once you guys are done with that, we'll have to configure AR Core. AR Core is, so if Unity is a framework for developing games, AR Core is Google's framework or library for developing AR applications. So AR Core is for Android, so if you want to make stuff with Android, you use AR Core. And if you want to use develop AR applications on Apple, use ARKit. Again, Android device, so I'm going to be using AR Core. Over that, there's like an abstract level that Unity uses called AR Foundation. We don't need to worry about that. It just renames a few tools that ARKit and AR Core have in common, and they like give their own proprietary name. It's just Unity's marketing. Don't worry about it. Once I explain to you guys and configure AR Core, we'll have to mess around with the player settings, because so if you guys have made games with Unity, like regular 2D or 3D games with Unity before, there isn't much to do in the player settings, because as soon as you boot up your project, you just start adding objects, writing scripts, whatever. Most of the player settings is done by picking the template that you'd want to use. However, with AR, there is a few things you need to tweak, because AR is still fairly new, and there's a lot of things that are like either legacy versions or depreciated, whatever. So you need to keep on updating them. One thing I found out the very, very hard way was, I don't think the minimum, so you guys need a minimum Android level for your phones. So this one is pretty new, so it's fine. But if you guys have anything older than Android 7, your AR applications won't work. It said the minimum API level required was 7 in all documentations I've seen, but when I tested something with Android 7, it did not work. So make sure you guys, I'll show you how to do that in a bit. If it sounds like gibberish, hopefully it won't be soon. Okay. So once you guys have booted up your project, you might stare at a screen that looks roughly like this. Since a lot of you guys have never used Unity before, I'll go over what you're staring at right now. So here, let's go from the bottom left. Yes, that's left. Here you'll have your file tree, so you'll see all of your files that comprises the project. So it's exactly what you think it is. Like if you guys have programmed before, so this is the equivalent of that. Here, the assets. This folder is a little unique, but right now what it's showing you is an extended view of all your files, or all the folders in a file. The opposite. So if you, it shows you icons. So if you want to look at, if you have two files that have the same name but a different type, for example, there is an animator and an animation. They both have the same name normally, but they're two different file types. So this helps because the icons are different. Don't need to worry about it now, but normally this section of the window right here is often replaced with a bunch of different things. Sometimes for animation, sometimes for like your inspector element, a bunch of different things. You'd put your own windows here. If you guys see on top, I'm not sure about Mac devices, but for Android, there should be a tab that says window, right, like on the very top. All those different windows, normally people tend to dock it here, okay? Does anyone have questions so far? Is everything okay? Cool. Then you have the object hierarchy here, the list of random stuff here. So Unity provides you with a sample scene and 3 different objects within that scene. So you have the directional light, AR session origin, and your AR session. Now your directional light is pretty basic. It is, well, it's a light source that has a direction to it. There are 2 kinds that Unity normally provides. There's a point light and a directional light. A point light is like, think of an orb that emits light. So it's omnidirectional, it goes in everywhere. With a directional light, it's exactly what you think it is. You can specify the direction at which it points at, what color the light is, all that jazz. Then you have, okay, before I move on to all this stuff here, you'll see this here, the inspector element. This is probably the second most important thing that you need to know. Each object is comprised of various different components. Every object is technically the same thing. What makes it different is the components that comprise the object. So every object in the entire, like in all of Unity, has the transform component, because you want to be able to move it around, unless obviously there are niche cases when you don't want something to move around at all, so then you never give it a transform component. With the transform component, you can specify position, rotation, and scale. You have the XYZ since we're in AR, but normally if you're in 2D, you will have X and Y only. You do have a Z component, but that's more for fake 2D games. If you guys have played Ori before, the hand-drawn game, it is a 2D game, but there are layers to each. There's a background element, foreground, midground. So all of those lie in different Z-axes. But when you look at it from the side, it's 1 dimension or 2. Then you have the light component. So this is what technically makes this object a light. If I remove this now, it's just an empty object with a transform component. So here you'll see like the various different settings. There are a lot of objects in Unity. I'm not going to, components. I'm not going to go through all of them because that's information overload and you guys don't need to know all of that. I will explain what each component does as they come up. Yeah, so you don't need to care about all of this. Lighting is a whole nother like second subject within Unity, or actually in all of game development. I covered a bit of it in the previous session, like light maps, baking, UV maps. Don't worry about all of that. Okay, so here you'll see your scene view. Right next to that, you'll also see your game view. The difference between the two is, so your scene view is what you'd see as a developer. So this here is the directional light. You can see a few rays shooting off into a specified direction, as well as the 3 different axes you can move it in. If you guys hold on to one of the colored handles, the arrow handles, you can move it in that axis. Or if you hold down onto the little square here, you could move it in. So for example, if this is the, okay, that's a Y. So this could be moved in the Z, in the Y and X direction. So if you hold down a square, it lets you move in 2 of those axes. So it gives you like more precise control instead of manually touching each handle and making it convoluted. Then you have the game view, so these are 2 different viewports. The game view is what a player would see. So normally you have, if you clicked on it now, you guys might not see anything because there is no camera. So you guys probably, hopefully you know this by now, but every game needs a camera. So that's what lets a player see stuff. If you hide or if you remove a camera, nothing is visible. Right now, there is no camera, so what you guys would see through a game view is it's blank. It's nothing. So that's why we're only sticking to the scene view. Technically, what we're making is not a game. It's more, again, making an AR game would require a lot more advanced stuff. We're sticking to the basics for now. I'm just giving you an introduction to how Unity works, like things that you need regardless of what you're making. If you guys want to know what we are making, should have covered that earlier, my bad. We're making like a prototype of a very, very simple AR business card or a virtual business card. So it's basically, you show an image to the camera and it'll display like VR components onto it, like whatever you want it to be, like pictures. Or you can do video, but we're not going to do video because I've realized that getting video to each one of you guys, if we put it onto GitHub, is a pain. So I'm just going to stick to raw images. Okay, so you guys should have all of this now. 1 second, let me just, okay. Let me do all of that. Yeah.
So, I have, installed the Unity, my downloaded Unity file.
Okay.
I have to download the Unity hub as well.
If you guys have installed the editor directly, that's fine. It's just, I prefer managing the Unity editor versions through Unity Hub. It just helps because, okay, so say suppose you guys have been developing a game with a certain version of Unity editor for a long time. Now, Unity has updated its editor. It's come up with a new version. If you guys want to migrate your stuff from the previous editor version onto the new one, Unity Hub helps with that. Because there might be, like if you just directly start, like just copy files, it might not work because some functionalities may have changed. Like for example, this will sound like a lot of jargon for you guys, but I covered this in the last session. Previously, Unity used to use a different rendering engine, you could call it, for lighting. But the company kind of just died because they had like an affiliation with the company. That company died, so Unity had to make its very own rendering engine. So now if you made games using the previous, I think it was called Enlighten, if you made it using Enlighten, now it won't work. So you guys will have to, like obviously I don't know if you guys have done it, but you would have to use Unity's new rendering engine. So that's why I prefer to answer your question, I prefer using Unity Hub, but if you have the editor version directly for now, it'll work. Maybe the... Yeah, you can. Sorry, should have done this earlier, just give me a bit. Does anyone have any questions so far? No? Okay, cool. While we wait. Oh, one more thing. Does everyone have an Android device? Do you guys have like an Android phone? Okay. So you kind of, since we're making it on like our AR application is compatible with Android specifically, we will need to use Android phones to test it. So basically, once you've built your project, once you've like made it, in order to test it, you have to build it onto your phone. I'll show you how to do that, but you need an Android phone for that. Like, how would you do AR without, like, well, a phone? So for those of you that do have an Android, do you guys mind, like, not necessarily sharing it, but just showing it to the people near you that don't have an Android device? Because we don't have too many spares. I do have this phone, and I can like show it to you guys, but then, yeah. Hey, bada bing, bada boom. Oh yeah, you guys probably got this. Ignore it. You don't need to worry about it. Okay, so all of what I just mentioned is here. So here you have the light, the different kinds of settings for that light. Then you have the the AR session and the AR session origin. So the AR session has a script here that's called AR session script. It basically manages the overall life cycle of your program. So it manages like a memory allocation. You don't need to worry about how it does it, just as long as it does its job. One thing you guys do need to know about is every program can only have one AR session script. If you have multiple, they will conflict with each other and stuff won't work. So make sure you have exactly one. It needs to have, every AR application built with AR Core needs to have at least one AR session script. By default, you should have one. Don't remove it. Then you have the input manager that does exactly what you think it does. Any inputs that would be taken from your screen are handled here. Second input handler. Now you have AR session origin. So as you can see, this is an object with various different components. It has also an AR camera here, so it's a child of this. So this is the parent, this is the child. I'm sure you guys know how those work. Then you have a bunch of different components here. So let's go over these one by one. An AR session origin is basically what allows you to, it maps real world items or the real world map onto your camera. So obviously like to your camera it's just a 2D image. It has no sense of depth, it has nothing. It's just an image on your screen, right? That's what input your camera gets. This script basically maps what it's looking at it tries its best to map it onto the real world. So like if I'm pointing at a table, okay, this white thing is a table and then you have a floor underneath it. Like it gives you depth, like it maps it out virtually. So when you decide to put an object, like an AR object, it'll know where to put it. Like it can tell elevation, it can tell orientation, like if it's a plane that's horizontal or vertical, things like that. Then under those you have the plane manager. This is what I was just talking about here. You can detect different kinds of planes. So if you want to stare at a wall, then you do vertical. If you want to stare at a floor, horizontal, so on and so forth. Then you have an anchor manager. So these two work in tandem. Here, the creator and the manager. Those basically let you create a physical point in space to where you can attach objects. So for example, I wanted to make the Android guy, the green dude. If I wanted to attach him, like, for example, if let's get the AC unit back there. If I put an anchor on top of that, I basically, so if I showed my camera pointed at the camera, it would know where in space to place the object, what orientation and everything. It's a point in space that, well, it anchors the virtual object to that point. Then you have Raycast Manager. This is to do with lighting and positioning, basically. You can fire out different rays. For those of you that don't know how raycasting works, it's an imaginary ray that's like shot out from a point. You can specify the point at which it originates from, and then what degree, how many rays you decide to shoot. All of this, you can use it to calculate a lot of things. It's a general purpose tool to just do a bunch of things. For example, if I had a point here, and I wanted the little Android dude to not be on top of it, to be like to the side and rotate it to 90 degrees. I can use raycasting, so I can originate a point from, so I can send out a ray from that point and like check its orientation, where it's hitting, like what's the first object it hits, how far away it is, how long it took, random things like that. I'm telling you, I'm briefly going over all of these because we actually don't need any of this. All we need is the AR session origin. So what we can do is start removing this. So if you hit the 3 dots to the right, you can just remove the component. We don't need any of these. So we can just remove all of that. Now here. Okay, so before I go on to this, we are going to be using, so if you type in, so here's how we can add components. You can search the various different names, and they're also categorized into different sections. If you just type in AR, you can see a whole bunch of stuff come in. Again, there's no point covering all of this because we're not using any of it. All we're using is, whoops, I don't know how to spell. Tracked Image Manager here. So this is basically an object that lets you take from a reference library. So how we're going to use this is we're going to have a library of different images. Okay, each image is going to correspond to a different object, like a virtual object that we're going to make. So for example, if I pointed at this bottle, the bottle would then show like a certain animation. If I pointed it at this little thingy here, it'll do a different animation, stuff like that. So it tracks the different images within that library. It lets you key them so they don't get mixed up. Okay, and then it also lets you go through. That's what this library here is. So we're going to make a reference image library. So the way we're going to do that is here. So right click onto your assets. Actually, wait 1 second. This is annoying me. Cool. Then go to create. Under create, you'll have. Damn, it's gone. Okay, wait. you'll see something called XR. There we go. And then go reference image library, not object. So once you name that, you can name it. I prefer to keep it by its default. Now we're going to get an object. Okay, cool. So here, when you pick reference images, there is a certain rule set you have to follow, because this is obviously these images will be handled by AI. The AI has certain strengths and weaknesses. So under Google's AR Core was made by Google, so all of its documentation is there. There are certain practices or qualities of a picture that of an image that you'd want to make sure is included. So for example, the resolution needs to be at least 300 by 300. This one you can artificially fake. You could always change the scale of the image. You don't need to worry about that. Make sure it's either in JPEG or PNG. This one's also pretty easy. Color information is not used. So if anything, you guys can go to the link here and you can, okay, I realize that you guys would have to manually type this out. But if you just search in best practices for reference image AR Core, you'll be redirected here. So yeah, color information is not used. So if you're relying on similar images, but that have different color, it's not going to care, because it will convert it to grayscale and check UVs, which is color information. Yeah, so images with heavy compression, that is something that you need to worry about as well. That's why, okay, so this 300 by 300 is a soft restriction, but it still is a restriction. So if you mess with the resolution of an image, or if you take a screenshot of an image and then use the screenshot instead, it'll compress and reduce the quality of the image. So if you do it enough times, AR Core won't know what it's looking at. I had this problem a lot. Yeah.
Also, something like this wouldn't work for the image.
Can you flip it over?
No, I'm just going to like this.
That one will.
That one.
Flip it over.
This one will work.
That will work. Yes. So actually, potentially, you never know, but there are. So Google itself has a service where you can feed it an image. It'll run its image library AI on it, and it'll grade the image. So it has a grading from 0 to 100, and well, 100 being a very suitable image, 0 being a very unsuitable one. If you go to the site, they do have two sample images, where one is a picture of a building, the other one is a picture of the globe. The globe works very well, the building doesn't, because it relies on color. So nothing over here, wait, here. Large number of geometric features or geometrically repeating features. So the back of a playing card has repeating patterns. So the way a reference image works is that it will generate random points on the image that it deems as unique. So it can map out what it understands what it's looking at. So the way the library works is you can have, well, okay, AR Core will recognize up to 20 unique images, not repeating ones. So if you have 2 cards, it'll only detect one of them, okay? But it can detect up to 20 unique images, and each library can have up to 1,000 images. You can have as many libraries as you want, but you can only ever use one library at a time. Obviously, this is what this only matters when you're doing super large scale stuff like Google Lens or the IKEA thing. Okay, then you have, okay, so these two kind of go in tandem with each other. So if you guys go through the GitHub link, you might notice that I used the Ace of Spades card image. Is that why you got an Ace of Spades card, or was that pure coincidence?
I was trying to have a phone before.
Oh, okay.
I tried.
We probably went to the same YouTube video.
Oh yeah.
Okay, cool. So I specifically, in the video that he looked at, it used Heart of Kings, or King of Hearts rather. I used an Ace of Spades. Reason being is because those two images don't have repeating patterns. Yes, thank you. So if you do 5 of diamonds like he did, the diamond shape is repeated multiple times. So sometimes, I think 5 might work because it's an odd number, so it isn't symmetrical. But sometimes, like I used a 4 of hearts, that didn't work. Oh, sorry, 4 of clubs, that didn't work. What we will be using, yeah, the little cards. What we'll be using is the assembly logo, because it has a bunch of different like artifacts on it, and they all, so it makes it look unique. Like as in, none of them are repeating. It fulfills all of this. It's a black logo, so it doesn't rely on any color image. All of that works. What happens when you don't use, like when your rating is too low? Like for example, if you violated several of these practices, what will happen is when you not during downtime, but during when you try to build your project during compilation, you will get an error that roughly says something along the lines of AR core image not supported, something. Okay, so here's the thing about AR documentation. There isn't much. There really isn't much documentation on it, and it's very annoying. But the little that is there are the problems that you'll most likely run into. So one of them is this: having an image that isn't good enough for a reference library. When I initially used, so my original plan for this workshop was to get little post-it notes and use the color of the post-it note to like use that as the reference image. Then afterwards, I learned the hard way that these are the practices. So a pink square doesn't work because there's no information whatsoever. It relies on being on being the color pink, which in this it doesn't even look at color. And technically, it has repeating patterns, and the pattern is just the one thing, pink. Obviously, it does have like a bit of paper texture, but that isn't good enough. Yeah. So here is the quality score that Google uses. You can pass it. You can use this to basically check the quality of the image that you're deciding to use. There are also external sites that do it. So if you want to like go there, you can check it out there. Okay, let's get to actually building the stuff. Wow, that's fun. Here. 1 second. Isn't that fun? You guys went through all of that. Okay, so the code here, 1 second, let's just go through it really quickly. There is just one script. So you can, I'll show you guys how to pick an image in a bit. Like we have assembly logos. What you guys can do is scan the image and then save it on your phone, or yeah, save it on your phone and get the image onto this Unity project. So like, or what you could do is, so here's the thing. Under here we do have an image, yeah, ace of spades.png. So that's the thing that I used. You could download it directly off of this. It's a working image. But the thing is, we don't have an ace of spades card here, like with us, unless you have a whole deck of cards. Or do you just have the one card? Oh, the Joker works, yeah. Joker is very good. So, nice, cool. Okay, so yeah, all of you can either just download the image here and then use that specific thing. It might not work because Ace of Spades often has its own art, because it's like every deck kind of has its own art for Ace of Spades. So you might want to use something that's there with like a present deck, or you can scan the assembly logo, which we'll hand out to you guys.
Is it upstairs?
I bought it downstairs. Check inside the box there. Yeah. So we'll add that later. Now, what we need to make is the one script that we have. Okay. So under create, just go to C# script. That's one way of doing it. Or, so we'll be attaching the script to the AR session here. You can do add component, and we'll name the script tracked. Wait, what did I name it here? Place tracked images. Okay, cool. So we do place tracked images, and you can just do a new script. It'll give it a name, create an ad. It'll create. So okay, this way is fine now, but I don't normally like doing this because it just creates it in the default path. I normally have a separate folder that has all of my scripts in it. This one. So if you guys open the script, you'll see a bunch of nonsense. That was me going insane and trying to figure out what's happening. Ignore all of that. I'll walk you through it. I also don't comment very nicely, so if you guys have problems with that, I will explain. Please don't judge. Okay, so essentially, you'll have your script here. Once you open it, it should open in VS Code. This is what your default script will look like. It'll just have a start method and an update. As the comments say, the pre-generated comments, start is called before the first frame. So if we were making a game, okay, I should explain some of this because you guys might know, want it. It might be relevant. A game runs in frames. Each frame is like a little picture. That's the best way to explain it. Like if you guys know film, the old film, it just showed a bunch of frames really quickly, right? By default, Unity runs at 60 frames per second, which essentially means it will show you 60 images in every second, and that generates video, okay? This method is called before the first frame. So if you want to initialize certain things, this is where you do it. Then you have update, okay? Keep in mind that if this is going over your head, you don't need to worry about it. We're going to remove all of this. This is what you'd use in a normal game. We're not making a normal game, we're making AR stuff, so ignore it if you'd like to. Update is called once per frame. So if you wanted anything done every frame, for example, checking if a certain button has been pressed, you would do it every frame. Check upstairs. Like for example, let's say I want to see if a player has been pressing, yeah? A picture? I'll show you. So it's a bit of a roundabout way. Normally you just Google an image and search it, but what we're gonna do is take a picture, save it onto your phone, and then put it onto your laptop, and then put it onto Unity. Thank you, bro. Okay, anyways, so yeah, update is called once every frame. So for example, yeah, if you're doing input handling, I want to check if a player has been moving left or right. I would call this function every every frame, and see if said input has been pressed. If so, do a bunch of stuff. We're not going to need any of that, so let's just remove it. What we do need is the stuff here. So, okay, 1 second. Let me just fix this. So if you go to the CS file, not the meta, the CS file, they'll have the script to load. Yeah, as you can see, there's a bunch of commented code. Ignore all of that. Below it is the actual thing that worked. This is how I test code and see if it works. I just make multiple instances and then just comment out the whole thing. I know it's bad, but it's the only thing my brain understands for now. Okay, so let's go over the script. We have one script, and it's actually fairly simple. It just looks like a bunch of nonsense. So here is the imports that you'll need. Just copy this and add it to your script. Just do that. Then you'll have the actual class here, or actually wait, let's. Yeah. So you'll use this is your normal stuff, everything until here. This is what you use for AR. Yeah, AR specifically, but it's under XR first because Unity refers to all AR stuff under extended reality because it includes VR and AR. Okay, then under the class you'll have here. You need this just to get. It's a convoluted thing, but basically you will need it for AR code to understand what you're saying. It's like the equivalent of namespace. Then, okay, so we're going to create an object that refers to our tracked images manager. So you guys remember that component, this one here. Where is it gone? Yeah. So this thing here, the AR tracked image manager, that object is referenced using this. That's what this is. Then we have an array that has all of the prefabs. Prefabs are, so you can so think of it this way. I have a player, and the player is an object with a bunch of different scripts on it, or different objects, components, right? Maybe a movement script, maybe something that lets it attack, whatever, jump, so on and so forth. Now, if I wanted to use that object in another scene, because each scene is a level, right? At least that's how it's traditionally done. You have one scene, and each scene is a level of a game. if I want to reuse that same object with all of its settings, all of its transform components, I would turn it into a prefab. Prefab stands for prefabricated, so like it saves everything, like saves the different components, and you can just reuse it. It's better than just copy pasting, because if you ever make instances of the prefab, if you make changes to the prefab, it will affect all instances. So you don't have to manually do it each time. That's why you don't want to just duplicate the object into various different scenes. You'd want to use prefabs. I'll show you how to make those. But this is basic, yeah? Yeah, exactly. Yeah. It's essentially a blueprint. Wait, sorry, I didn't catch that. Yeah. If you drag the object onto your file, it'll turn it into a prefab. I'll show you in a bit. I'll just go over this, the array here. I'll just go over the script and I'll tell you, like, I'll show you what the script does, why it does things, and then I'll go over implementing. So normally what your workflow will look like in Unity is you arrange a certain few things, like I need a player. You'll make a player, then you'll need, I need to move the player. So you'll make a script for it, write down the script, give it to the player, and then so that's what you'd consider project settings. Whenever you attach a script to a different player, or whenever you manage stuff in a scene, like you place certain objects in a scene, that is project settings. Then that's one side to it, and then there's the scripting side to it, where you write code like this. There isn't much code that you have to write. This thing is like technically only 50 lines. So yeah, okay. I'll show you in a bit. If you're a little lost, just follow along with me. Just go over the. So this is what we need. So here, I just copy all of this stuff. Put it here. Then we have a library. This is basically like a keyed array. This is what lets us make sure that each image is specific, like the reference image will correspond to a very specific prefab. So like I mentioned before, for example, if I point at this bottle, first of all, this bottle actually isn't a good reference image, but if suppose I was using this bottle, I'd only want the Android dude to come out if it saw the red top of this bottle. If it had like another image, for example, it'll show something else. So that's what lets this dictionary here is what lets you do that. It's like a keyed array. If you guys have trouble with syntax, honestly, don't worry about it. Then you have awake. So it's a little redundant, but awake is what's called before start. So first start, there are, like internally, the way Unity compiles stuff during runtime is it'll first call the awake method, then the, so we're going to give you, we don't have many, but we're going to give you those little things there. They have the the assembly logo. Let's take a picture. I'll show you what to do. But yeah, so the awake function is what's called right before the start function. Now that might sound like they have the exact same like use cases, but normally you use start. If you want to instantiate or declare something global, normally like in small programs you don't need to care about awake. But when you're making a large game, awake has more meaning or weight to it, because it has to do with like memory management and stuff. So if you're declaring global stuff, you'd want to do it on awake. Right now, we don't need to worry about it. I'm just teaching you general practices that you might remember eventually or occasionally. Then you have on enable. So this is just a glorified way of doing on true. So on enable means if this component is enabled, it will do this. So basically it will add, so look at the tracked images manager and it'll check. So this is the one and only function that we have here. There's only one function that makes up the bulk of the script. You guys have probably seen, like a few of you guys have probably seen this already, but yeah, we have this one method here that manages all of, like it checks if an image has entered into a scene, if the said image has moved, what kind of image it is, or if it's left the like view of the camera, and then we'll add it to itself basically. So this is if it enters, this is if it leaves. Cool. Then you have the actual method here. Okay, the 3 different sections. If you guys think this is bad code, that's because it is. There is 3 for loops, and within 3 for loops. Within each is an if statement. It's a bunch of nested nonsense, but for now it's fine. So you have 3 main parts. The way you can distinguish it is there's the added, the removed, and the updated. Okay, so added is what happens when wait, okay, first things first, let me just add all of this. So added is what happens when an image from the reference library enters like the view of a camera. Okay, so when that when it enters, it will basically cross-check its name. So we'll do a string comparison. This is a weird way of doing it, but it's fine. Basically, what you want to do is, the way we're keying these images to their AR objects is we're making sure they have the same name. So here, the name should be the same as the 2D images from the reference image library. So if I'm making an AR prefab called the little Android dude, I'd name that prefab red cap, and I'd name this reference image red cap. So that's how it can tell, like, okay, this belongs on the red cap, basically. If like put in layman's terms. Then you have updated. So this is fairly simple. This just constantly checks if the image is still present. If it's moved, then maybe if it's moved, then you'll move the prefab to where the new image is, like follow its position basically. And this is what happens if it's removed. So if you remove the image from the view of the camera, then said AR prefab has to disappear, right? So that's what this is. Very simple stuff. You don't need to worry about it too much. That should be right. Sorry. Copy it here. Let me fix this stuff. I won't go through this line by line because, well, it's commented and you don't need to worry exactly about what it's doing. This is more to teach you like concepts rather than functionality. One second. So when you hit save and you open this, it'll compile the scripts and it'll go through. Okay, so you get errors here. Current context. Why? Why are you lying to me? Okay, you can remove all of this. Alright, give me a second. Oh. Oops. Why? Because we don't have the dictionary. Cool. Okay, so now the script's ready. At least it should be. If you guys have any errors, does anyone have any errors? There shouldn't be. Just Control A, Control C. Cool. Okay, now let's set up the actual image. This part is the weird part that doesn't require a computer. 1 second. So the way I had done this was I took a picture of like the card I was using, and then put it on, like I converted it to a PNG and sent it to my computer. You guys have the assembly logos, right? Yeah, that's the one. Does everyone have them? Cool. So take a picture of them, but like not through your camera. Do you guys have Microsoft Lens or anything of the sort? Use that. So like, because basically you want the picture to be straight, because if you take it like at an angle, it will only recognize that image at an angle. So just so it's neater basically. Do you have the assembly logo? Okay, yeah, wait. I think that's didn't work last time I tried, but okay, cool. Yeah, you can use this one as well, but that was the object. So basically I made an AR object and slapped the assembly logo on top of it. So what I did was whenever I showed the Ace of Spades card, the assembly logo would pop out in front of it. In this case, it might look a little weird because it's like if you show the assembly logo, another assembly logo comes on top of it. Makes no sense, but it's just to show you functionality. Obviously, you can change all of this. You can even add a video onto it, but I'll show you how to do that in a bit. So, okay, I'm just going to download. Where is it? This one? Oh, no. The assembly logo PNG. Oh, okay. Oh, right, I named it the same thing. Thanks. Yeah, so I named it the same thing because remember how I said in the dictionary it's it's C-Res library, so it needs to be the same name. I didn't name this assembly because the picture I was trying to look at. So, for example, whenever I pointed at the Ace of Spades card, it will look at that image and it'll see that it's been named, the said image has been named Ace of Spades. So it'll check the prefabs and like the array of prefabs that we have, and it'll check if we have a prefab named Ace of Spades, and then it'll display that. That's why I named this Ace of Spades as well. I just forgot about it. Okay, it should have. Okay, this time let's name it like so, just so it's easier that way. And then we'll take the assembly logo and drag it directly here. So now under reference image library, so once the assembly logo is in your project folder, click on the reference library, add the image and simply drag it onto it. Make sure that the name is the same. Now what you want to do is, you don't have to do it, but it helps a lot. Specify the size of the object. So I think the logos, if I remember correctly, they're like 5 centimeters by 5 centimeters. So what you would do is 0.05 because it's in meters. So it's square. The other thing is kind of estimated since it knows what it's doing. This basically checks the physical size. So sometimes you might have images that look similar, but because they have different sizes, the AR core is able to tell them apart. So specifying the physical size of the object that you want to look at helps. Now once you've done that, yeah? Oh, right click, create, if you scroll down, XR, Yeah, and then reference image library here. So go to create, scroll all the way down to XR, reference image library, and it'll create it'll create it automatically. This should be here. Okay, so okay. Now under the script here, we had an array named AR prefabs, right? So if we go here, we can add something to the list. We will add our object. For now, let's just remove that. Let's make it so. We're going to create a 3D object, and let's make a plane. Okay, so plane is just simple, technically 2D object. It's just a square. So then we can just drag your assembly logo and just put onto it, and it will orient it. Obviously we don't, okay, if you guys want, you can keep it upside down, but why would you? So turn this into, oops, and it'll turn it right side up. So under your rotation, under the transform, you can rotate it 90 degrees. That's, so like I mentioned earlier, so if I hold this handle here, I can only move it in the X direction. So if I move my mouse up and down, it won't do it. But if I hold on to this blue square, for example, I can move it in, yeah? How did I? This part? Okay. So right click here, create where is 3D object? Oh, sorry, my bad. Here, create 3D object. Under right click under hierarchy, 3D object, and then plane. Once you make the plane, take the PNG, whatever PNG you guys decide to use, and just drag it onto the plane. It will automatically add the shader to it. So by default, okay, wait, let me delete this. Oh, that's all right. So by default, here are the things on a plane. So you have the mesh renderer, which is like, the mesh you can think of as like a wireframe. It gives the physical texture to, not the texture, the physical form of an object. The filter, it's basically like a manager. These two are dependent on each other. It has to do with runtime. Colliders, now we won't be using colliders here, but colliders are important. We did cover them in our first Unity session. So basically, colliders are like the physical collisions of an object. So if you don't have a collider, objects are able to pass through each other without ever interacting, okay? Because an object might have physics applied to it, like for example, if gravity can pull it down, but if it doesn't have a collider, it's never going to interact with another object, okay? So colliders are basically like the physical wall, you can think of the object, the boundaries of an object. This gives it, this means that it has a physical collider, it being a 2D plane, like a tissue paper. We can remove it if we want, it doesn't matter in this case. But most of the time you'd want to remove it. Here we have, so this is the shader or the material you would apply to your plane. So by default it comes with your standard shader. If we take this and we drag it onto here, basically what it does is it gives it that shader. So the PNG, it turns the PNG into that shader. Shaders have a whole thing. You can edit, like if you hit edit, you see the amount of things that come up, but you don't need to worry about it. Then you have different kinds. This stuff was again more covered in our 3D because it matters more there, like how light interacts with the shader, like what the opacity is, what its roughness. So it can be metallic or chromatic, all of those kinds of things. Here they don't really matter because it's just the PNG. We'll do the same thing under Y. Let's rotate it 180 so it's facing us. Because basically when you point the camera at it, this is how it's going to display the object. So if I did this, oops. If I did this, whenever you render the object, so for example, if this was your assembly logo, it'll show up like that. So if you do it, if you remove this, it'll show up exactly flat enough. So just to add some variety, let's do that. Okay, I think that should be it. Now, if we take this plane and let's rename it. So if you hit F2 over the object, it'll just rename it. Let's name it to that's nice. Assembly logo. Rename it to assembly logo and drag it here in some general space. We'll turn it into a prefab. Okay. Now, if we double click the prefab, we get to edit the prefab. So this is useful because if you are making a bunch of different objects and you decided to, or like different instances of the prefab, and you're like, okay, maybe I don't want this texture, I want another one. If you edit the prefab and change it directly here, it'll change all instances or children of that prefab. So here, okay, it's renamed assembly logo. It's the same thing, you don't need to worry about it. Now if we hit back, also its position is also affects it. So for example, this is 0, 0. Okay, let's say this is 0, 0. Now I have multiple levels that all have my instance of the prefab starting at like point A, point B. If I change the parent, so if I change the position of the prefab itself, then it will offset all origin points in the children by that amount. Like so, for example, if in level 1 I started 0, 0, my player started 0, 0. At level 2 I started 1, 1. If I edited this prefab and did like 1, 1, 1, it would add 1 to all the origin points. So in level 1 it would be at 1, 1, 1. At level 1 it would be 2, 2, 2, like so on and so forth. It offsets it basically. That's more or less it. So again, very basic thing. You guys can just go back and then you'll go into the normal editing. As you can see, this is blue now. That means it's a prefab. It's using a prefab. Now, if we go, back here, you can see the script that we added. It had the an array. If we add an element to it and just drag the prefab, not the image, the actual prefab itself, make sure it has the same name as the reference image. So if you go here, assembly logo, it is case sensitive, so make sure your casing is correct. Okay, I think everything is set. Now comes the weird fiddly part. So this is like the general thing. If you do Control-Shift-B, or if you go to File and then Build Settings, you will come up with this thing here. Okay, we're making an application for Android, so we'd want to select Android. Then let's go under Player Settings. Okay, under Player Settings, you'll see a bunch of different stuff. First things first, go to XR plugin management. Then we go to AR and take AR Core, Android. If we downloaded the Apple kit, the Apple module initially when we were installing different Unity editor versions, we would have the Apple version as here as well. Since we're only doing Android, I'm only installing this part. Cool. Now that that's done, go to AR Core, and this application specifically requires you to use AR Core. So if your device doesn't support AR Core, then like it won't work. Like if you tried building the project onto to an Android device, I tried it myself. If you made this optional, okay, your project will still run. So that means it will build onto your phone, but nothing would happen. It would just be a black screen with nothing on it. So that means it's required. So the only way it runs is if it's a compatible device. If it isn't a compatible device, you will get a build error on Unity's console here. So every time I forgot to mention, but if we come up with any errors, it'll all show up here, as you guys might have seen earlier. Yeah, so under requirement, we do that. Then if you go back to player, you'll see a bunch of different settings here. If you want to order pizza, you can order pizza now.
Okay.
Up to you.
Do you want some?
No, after you can use it. I mean, same thing. Karthik is here. Some of the other dudes are here as well. You can let them. Some of the other guys, like whoever wants pizza. Okay, that's fine. But if you don't want to order, then. Okay. Under here, you guys can, yeah? You can't see? That like this tab here, that might have been because, okay, so when you're installing the Unity editor, you can add different modules to that editor that allows support for different platforms. Make sure that you have installed the Android SDK. It was installed? Sorry? No, Android Studio. Oh yeah. You have a bunch of other like dependables that come installed. Like for example, one second. Here, if you go to installs, go to settings here, add modules. Yeah, all of this is here. Make sure you guys have this, otherwise the application simply won't work. You should have OpenJDK and these tools here. This all is done, so I don't need to worry about it right now. This computer is a little slow, so I installed it beforehand. Now, okay, is everyone here on this part? This is where this part is like a bit of a tricky part. You normally do this before, but I wanted to show you AR functionality first before I mess around with the settings, because all of this looks very arbitrary and nothing makes sense. Oh, whoops. So here you would have your company name and product name. So when you launch the app, this is what will show up. We're not really publishing this to anyone, so it doesn't really matter. Under here, okay, all of these settings. So all of the settings should look like this. I'll make the window a little bigger. If you want the project to work, it should be like this. Okay, let's here. So all of this should already be done by default because we picked AR as our template when we were making the project. So these are done for us. Right here. Okay, all of this should be the same as well. Now under other settings is where you'll have most of the things that you need to change. So OpenGLES 2, the depreciated version, again it's depreciated, we don't care about it, remove it. So we're only using this API. Other than that, all of this should be the same. GL resource filters. All of the light map stuff, please don't worry about it, it's a whole another science. All of this is the same. Okay, this, untick this, so it doesn't, normally you'd specify your own project name, sorry, package name, but I'm good with the default, so I'm going to just use the default, which is your company's name, which is this thing back here, dot your project name. Now here's the part that lied to me. So Android 7 is the minimum that AR is compatible with. We're going to make our program run only if the Android device we're building it on has Android level 7, okay? But from what I've learned, AR Core, the Google application AR Core, actually needs, I think, 7.1. Because I tried devices that have Android 7 exact, it didn't work. If you guys are using Android Studio to emulate your Android device, I did try that. I wasn't able to try it because my laptop wasn't strong enough, but make sure that you're using x86, so ARM. So over here under target architectures, this part, make sure the two ARMs are ticked, so ARM v7 and ARM 64. Those are the two architectures that we're using. We're not using x86. By default, if you guys are using Android Studio, the virtual devices that you guys are going to make, if you guys are using it, you don't need to worry about it if you're using a physical phone, but if you want to emulate a virtual device, make sure that when you're making the device, it's using ARM architecture, not x86. It will say like, oh, your stuff's going to run slower, which it will, but if you have a good enough computer, fingers crossed it should run. So make sure that these two are ticked, leave these unchecked. Target devices, leave this default, none of this matters. Chrome OS input emulation, if you do decide to run on x86, what this does is basically, obviously, if you're emulating on a phone, if you're emulating a phone on your computer, you're not going to touch the laptop screen or your computer screen. You're going to use mouse inputs, right? So this emulation basically translates that. So a left click would be a tap, a right click would be like a long press on the phone, like things like that. It translates all your phone inputs into cursor and mouse inputs. TV compatibility, all of that is not needed. Aside from that, I think everything is fine. Okay. If it says, okay. Yeah, everything should look like this. As long as all of make sure you're using IL2 CPP for the scripting backend. We don't need to worry about that. This is all the same thing. Cool. Okay, now comes a bit of an annoying part. So, could you take us to Meeta? Can you message her and ask her what the password was? Message me the password.
Should I start giving the wires?
So those of you that have an Android phone, do you also have a wire? If you don't, we do have spare wires here. We have one Type-C here and a bunch of micro USBs. Thanks. So once you plug it in, one second, yeah.
Oh, okay, sorry, this one. I'm confused.
Hi, damn, it's close.
Why is she yelling at me?
Maybe she's in a meeting. Oh shit. Understand. Hope he gets it. Okay, this part I can't show you on the screen here, so I will show you here. So go to your settings.
Should I bring the camera closer so that?
No, it's fine. Okay, I'm gonna. I should call it pro gamer move. Cool. Okay, I'm going to see this in reverse. So go to your settings and then search build number. Okay. So you guys should have like an option that just tells you the version, the build that your phone's currently using. Just tap that 7 times and you'll go into developer mode. Because if you want to debug stuff, you'd need to go into developer mode. So just spam click that a bunch of times. I already did it, but once you do that, you'll have to put in your password. Tell me, okay. Once it'll say, you'll have a little message that says, oh, you're in developer mode. Okay, for those of you that don't have an Android device, I will come around and show this to you. Okay, wait. 1 second. So once you go into developer mode, go into search developer options. Okay, so once you're there, enable USB debugging. So if you scroll down, you'll see a little option that says USB debugging. Allow it. And then you'll have a prompt that's like a security prompt. Say allow. You'll also have. I like to keep this on. There's an option that says stay awake. So as long as this is plugged in, you don't have to the phone will never switch off. It's just useful when you're like, oh, I need to debug something. Go back to the phone because it's already tedious as is. Once you do that, I'll show you what to do. I'll come to you guys in person for those of you that don't have an Android device and show you what to do. But once you do that, your phone is set up. So you're in developer mode and now everything's set up. Refresh here and you'll see your device here. Default device does work, but I prefer selecting the specific one. Once you do that, you need to add your open scene. So whatever scene you have open here, click here and you'll add it. So when sometimes you don't want to build the whole project. Sometimes you want to build a specific scene and test if that scene works or level. If you ever hear me say scene, just replace it with the word level in your head. So like for example, I don't want to keep having to build my entire game over and over just to test out level 3. So what I can do is I'll only build level 3 and see if that in itself works in its own pocket space. Once I do that, switch platform. Oh, make sure you switch to the Android platform. Let the scripts compile. Just give it a bit. Okay, once that's done, make sure scenes have been added, it's the right phone. Now if you hit build and run, let's say, honestly it doesn't matter, so let's go to downloads and do it here. Name your build, so test.
Ask if everyone is following. Do you think everyone is following?
Are you guys following so far, or is anyone lost? Probably, right? Okay. Okay, one second, I'll come to you.
Creator into developer.
Actually, no, that one doesn't work in the other two.
Why not the one under the bag?
I'll stop streaming. Wait, get one of the assembly logo things. Isn't that fun? Didn't work. Why isn't it working?
Just for you or for them too?
No, for me. For me specifically, right?
Some other people at work, right? Yeah, it's fine.
What's up? Maybe in a while. I need you to help me. Yeah, I'll tell you. We're done. Stop streaming.
Yeah.
Okay. Are we done by now?
Should we end it?
Yeah.
You want to say like a quick conclusion?
How long's the thing?
We're done. I'm stopping the stream.
You did this workshop?
Are we done with
If you can get it running, I mean,